This clip's going to focus on all the games that involve students' hands, or a few of them that are really valuable. Joe Bowler from UCubed often says that we don't let our students use their fingers and their hands enough in maths, and then we get that whole using them under the desk type of situation, whereas we really want to encourage them to use them, and then what will happen is they'll get confident in their number skills enough that they don't really need them. But if we make it a shameful thing, it really can be quite sad when they feel they need to hide them, when sometimes your fingers can be a good mathematical strategy. As an adult, sometimes I find myself using my fingers to, count the tens or hundreds or count back in certain situations, or make sure that I have accounted for everything that I needed to solve. So in Foundation, one of the great games I like is just One More, One Less, where one student has their hand like a fist, scissors, paper, rock. I often use, without them saying scissors, paper, rock, but that sort of shaking motion. And it's like, one more, please. And say they pull out 3. Then the other partner has to pull out 4, because that's one more than 3. Alternatively, the other partner can just give them 1, as in one more finger, and you can see it's 4 there. So a nice way to practice One More, One Less. Same thing, just for one less, please. Say they pull out 2. The other partner covers the finger or taps it to push it down, and 1 less is 1. So it depends on the version you like best. In grade 1 and grade 2, I use it for difference between a lot. So similar game, it's just how many more or how many less, or what's that difference is the chant. So what's the difference? Say we pull out 3 and 2. We pull it out at the same time now instead. And I pulled out 3, you pulled out 2. So you put your 2 on top of my 3. And then we can see the difference here is 1. So the difference between 3 and 2 is 1. And often I'll have this partner say, I have 1 less. And this partner says, I have 1 more. And the difference is 1, is what we both say. And then on and on we go. If it was 5 and 3, similar thing. I have 5, you have 3. So I put my 3 on top of your 5. So we can see the leftovers are 2. So the difference is 2. Not so much the leftovers, because we don't want to get into division, even though 5 shared between 3 is 1, remainder 2. So you can use it like that a little bit, but more so it's great for difference between, because it's visually clear what the difference between the two numbers is, up to 5 using fingers, or up to 10 if both partners are using 2 hands, but I don't have 4 hands. In grade 4 to 6, we often use a finger strategy for the times tables. It's not the ideal strategy. Our ideal strategies are, doing the 4 times tables as a double-double, the 8s as double-double-double, the 9s as 10, so a group of 10 of whatever you're grouping, and then take away one group. So those are the preferred strategies. However, some students just don't have the working memory to hold those numbers in their head and to then figure out, say, 9 groups of 6. Well, I'm going to go 60, take away 6, and then figure that out. It just becomes too much when the numbers get too big for certain students. So we at least want them to have a strategy to make the times tables efficient for them, rather than having to count by 9 6 times, or by 6 9 times. So with this strategy, it's not the 9s finger trick. I'm sure you've all seen that, or a lot of you have. But with this strategy, the thumb is the 6, this finger is the 7, the middle finger is the 8, this finger is the 9, and this one's the 10. So just assign those values to your fingers. So 6, 7, 8, 9, 10 is the little finger there. Then we're going to do, all right, so let's say we do 8 groups of 8 to start with. So we put our 6 finger down on this hand, 7 and 8, because it's 8 on that hand, and then the other hand's 8 as well, because we wanted to do 8 groups of 8. So the 6 and 7 and 8 finger go down as well. So the important thing to remember is if you're doing 8 groups of 8, the 6 and the 7 finger go down too. The fingers that are down are worth 10. So we've got 6 fingers down at the moment, 3 on this hand and 3 on this hand. So that then is 60. And then these 2 and 2 that are left, we don't add them. For this situation, it doesn't really matter if you add them or multiply them, but for every other equation it will, so we multiply them. So 2 groups of 2 is 4, so it's 64, and we've got our answer to 8 groups of 8. Seems like, oh, will it work for everything else? Well, let's check. So let's do another one that students find tricky, which is 7 groups of 8, say. So instead of 8 groups of 8, we're doing 7 groups of 8, so we'll just put 7 down on this hand and 8 down on this hand. So 6 and 7 go down on this hand, 6, 7, and 8 go down on this hand. It really doesn't matter which hand you do because multiplication is commutative. So you could do it either way, it doesn't matter. So we'll now check how many fingers we have down. So we have 3 down and 2 down, so that makes 5 tens. So we've got 50 something in our answer. And then we've got 3 times 2, 3 times 2. I like to bash them together just to go times, to make almost a times symbol. So it's not just add it, so it's not 55. It's 3 times 2, so 56 is our answer to 7 times 8. Again, it's just a strategy I teach to those students that, no matter how much practice we do, no matter how many array practices we do with string to try to get those efficient strategies out, for the 6s, 7s, 8s, and 9s, it just doesn't seem to be working for them. It's really an accessible way to access the 6s, 7s, 8s, and 9s, which are the harder times tables. It does get a bit harder, actually, when the numbers are a bit lower. So let's practice, say, 6 times 7. So 6 means just the thumb goes in, and 7 means the 7 and 6 finger go down. So that's now 30, because we've got 3 fingers down, so that's 30. And then we go 4 times 3. 4 times 3 is 12. So it was 30 plus 12, 42. So you can see, actually, when the numbers are lower, it's a harder strategy than when the numbers are bigger. Because say I had 9 times 9, I would go 9 down on one hand, 9 down on another hand. So the 6, 7, 8, and 9 fingers on one hand, and the 6, 7, 8, and 9 fingers on the other hand. So I've got 8 fingers down, 80, 1 times 1, 81. So some of the easier times tables in that list, in that category, are harder with this finger strategy, and some of the hardest ones are easy. But it could be a good strategy to show your students, just to give them an additional option. And again, fingers I do love using for maths, whether it's just a counting back strategy. So say we're teaching counting back now, we're going all the way back to grade 1, even prep, and some grade 2s who need it. Say we're doing 8, take away 3, put 3 fingers up, 7, 6, 5. So it reminds us when we need to stop counting back, because we've put the number that we need to count back by up. A lot of teachers will say, instead, let's do this. Let's start with 8, and then we'll go 7, 6, 5. But then the students often don't remember that they have put 3 down. Whereas this method, if I said 51, take away 3, and you can count back from 51, then it would be 51 is my starting number, put 3 up because I'm taking away 3, 50, 49, 48. So that strategy can help me. That finger-based way of counting back can help me with 2-digit subtractions, where I'm subtracting 1-digit number from 2-digit number, whereas I can't put 51 up in fingers and then just put 3 down because I don't have 51 fingers. So when you're using finger strategies with your students, do think about the most long-term finger strategy for them. In terms of, if I'm teaching a counting back strategy, I'd always usually go with the 3 up and then count back by that 3 if I'm taking away 3, rather than put 8 up and take away 3.